Hey guys, today we're going to be talking about uniform motion. So this is actually something we see in real life all the time. You're probably not going to be measuring the distance and speed of planes, but it is a real life application that you could know and appreciate. So we're talking about distance, rate, and time. So if you think about driving in a car and going somewhere, to figure out how far we've gotten, what do? We multiply the speed at which we're driving times how long we've driven. So the when are we going to get there question can get answered. So the formula for this is distance equals rate times time. I like to call it the DIRT formula. D equals RT, DIRT. D stands for distance, R stands for rate, T stands for time. There's going to be two types of problem. One is going to be talking about equal distance. So two things going the same distance. To figure out and solve those problems, we would do RT equals RT. And then the other one is they might tell us how far apart they are. So the distance apart is the other setup. If we're given two items and how far apart they are, then we're going to do RT plus RT equals total distance. So this says, two small planes start from the same point and fly in opposite directions. So we have one plane here going to the left, we have one plane here going to the right. The first plane is flying 30 miles an hour faster than the second plane. So I still am going to use a chart to organize my information. So we have plane 1, we have plane 2. For each of them, we have a rate, a time, and maybe a distance. So let's see what we have. The first plane is flying 30 miles an hour faster than the second plane. So when it's talking about miles per hour, that's going to be our rate. So one plane is going 30 miles an hour faster than the other. In 4 hours, that means they're both flying for 4 hours. So the time is going to be 4 hours. The planes are 1,160 miles apart. So distance apart is going to be RT plus RT equals total distance. If they don't give us any information on distance, then we'll be using the other formula. So now we're going to take these facts, multiply them together. So 4 times x plus 30 plus 4 times x equals 1,160 miles. 4x plus 120 plus 4x equals 1,160 miles apart. Combine like terms, 8x plus 120 equals 1,160. Subtract the 120, 8x equals 1,040. Divide by 8. X equals 130, sorry. Find the rate of each plane. So for this one, our answer box will be both of them. So plane 2 is going 130 miles per hour, and plane 1 is going 160 miles per hour. In example 2, it says a long distance runner started a course running at an average speed of 6 miles per hour. 1.5 hours later, a cyclist traveled the same course at an average rate of speed of 12 miles an hour. How long after the runner started running did the cyclist overtake the runner? These tend to be a little bit tricky. See if you can make your chart. We have a runner and a cyclist. Do they tell us how far apart they are? Nope. So we're doing the rates and the time. See if you can fill in the rates and the time. So the rates are easier. Think about this logically. Who is going to take longer, the runner or the cyclist? 1.5 hours later, the cyclist did the same course. So that means that the runner was running for 1.5 hours. How long after the runner started? So we want to know how long did the runner run? Till the cyclist caught up. It doesn't say anything about distance, so they're going to be meeting up. So RT equals RT. 6 times x plus 1.5 equals 12x. 6x plus 9 equals 12x. 9 equals 6x. We get x equals 1.5. So if x is 1.5, 1.5 plus 1.5 is 3. So the runner ran 3 hours. That's crazy. I would never run 3 hours. The runner ran 3 hours until the cyclist caught up. All right, usually we practice a couple more of these just to make sure we're good at them. I would try a few. Let's do number 25. A helicopter traveling 130 miles per hour overtakes a speeding car traveling 80 miles per hour. The car had a half an hour head start. How far from the starting point does the helicopter overtake the car? All right, so we have rates, times, and they're going to be catching up to each other. So we're going to make a chart. We have helicopter and car. Helicopter, car. We have rates and times. So it says the helicopter is going 130 miles an hour. The car is going 80 miles per hour. The car had more time, a head start. So that's our rates, our times. So the helicopter is X. The car is X plus 0.5. So we're doing an RT equals RT. 130 times X equals 80 times X plus 0.5. 130x equals 80x plus 40. So we get 50x equals 40, x equals 0.8. So that means that the time is 0.8 of an hour, and this time is 1.3. I don't think that answers the question though. So if we look at the question says, how far from the starting point? How far? What's that asking? Is that asking me a time? It doesn't say how long, it says how far. So what would we do to find out how far? So how far is asking us what the distance is. So we go to a distance formula, D equals RT. You can either do the helicopter or the car. We should get the same answer regardless. So the helicopter was going 130 miles an hour for 0.8 hours. Or we could do the car. The car is going 80 miles per hour for 1.3 hours. So let's do the math. 130 times 0.8 is 104 miles. So the answer to this question is 104 miles. Let's see. Let's do one more. Let's do 29. A commuter plane provides transportation from an international airport to surrounding cities. One commuter plane averaged 250 miles per hour flying to a city and 150 miles per hour returning to the international airport. The total flying time was 4 hours. Find the distance between the two airports. So one more time, this is asking us for distance, but we need the other information first. So we have to and from. We're going to the airport, from the airport. We need our miles per hour and we need our time. This is a good one because they only tell us the total time. So we know it's going 250 miles flying to and 150 miles returning. It tells us the total time is 4 hours. So what do? Do I just break it up 2 and 2, 3 and 1? How do I do this? I know the total flying time is 4 hours. How long does it take me to get there? I don't know. X. How long does it take me to get home? Well, we take the total amount of time, 4 hours, and subtract the amount of time we used. So 4 minus X. So hopefully you're getting good at that strategy now. So we're doing RT equals RT because our distance isn't changing. We're going to and from the same place. So 250X equals 150 times 4 minus X. 150 times 4 is 600 minus 150X. 400 X equals 600 divided by 400. X equals 1.5. So it takes us 1.5 hours to get there, 2.5 to get home. But that doesn't answer the question. The question is how far? So again, we have to go back to the distance formula. Distance equals rate times time. 1.5 times 250 is one option, or 2.5 times 150. So I believe that would be 375 miles if my math is correct. It is. So when you're doing these problems, be careful to answer the question. Read them carefully. Ask for help if you need it. Take your time and make sure your answer makes sense. Good luck to you.